Next, let us see properties of square roots and cube roots. We'll see what are square roots of positive and negative numbers, and then we'll see multiplication and division of square roots, cube roots, etc. Let us start by looking at properties of square roots. So first of all, positive numbers have two square roots. So any positive number has two square roots, and one of them would be positive, the other would be negative. And these square roots, they have the same magnitude but opposite signs. For example, square root of 16 could either be plus 4 or minus 4, because if I multiply plus 4 by plus 4, I'll end up getting 16. That is, plus 4 squared is 16. Similarly, if I square minus 4, I'll also end up getting 16. So square root of 16 can be either plus 4 and minus 4. So they are of the same magnitude, but they are of opposite signs. So similarly, say square root of 25 can either be plus 5 or minus 5. So any positive number has two square roots. Now what about a negative number? So a negative number has no real square root. Why is that? Because let us take a number x. Now if I multiply x with another number, there is no way I'll end up getting a negative number. Say if x is positive, positive multiplied by positive will be positive. If say x is negative, negative multiplied by negative will also be positive. So there is no way I'll get a negative number. So a negative number does not have a real square root, and also it cannot be represented on a number line. For example, if I say something like square root of minus 9, so the square root of minus 9, this is not a real number. Now what about square root of a square? So for any positive integer x, that is x is greater than 0, square root of x square will be x. For example, square root of 36 will be 6, since 6 squared is 36. So for any positive number x which is greater than 0, the square root of x squared is x. Now let us see some multiplication and division properties of square roots. Say for example, we have square root of a multiplied by b. This we can break it down as square root of a multiplied by square root of b. Similarly, say we have square root of a upon b, we can break it down as square root of a upon square root of b, provided b is not equal to 0, because division by 0 is undefined. Say we have square root of 12 into 3. So this I can rewrite it as square root of 12 into square root of 3. Similarly, say I have square root of 49 upon 4. This I can rewrite it as square root of 49 upon square root of 4, which would be 7 by 2. Now let us understand cube roots and perfect cubes. So first of all, what is a perfect cube? A number x is called a perfect cube if it can be represented as x equals say a cube, where a is a whole number. And in this case, x, a is called the cube root of x. For example, say we have 27. So this is nothing but 3 multiplied by 3 multiplied by 3. That is 3 cube. So 27 is a perfect cube because I'm able to write it as cube of a whole number. I'm able to write it as a cube. So 27 is a perfect cube. And now cube root of 27, which I'll write it like this. This is how I represent cube root of 27. This is nothing but 3. So in this case, cube meaning cube root of x is a. It is cube root of a cube. X is nothing but a cubed is a, where x is a cubed. Now what about the sign of a cube root? So one interesting thing is cube roots always preserve the sign of the original number. So what do I mean? Say what is a cube root of 8? So 8 is nothing but 2 multiplied by 2 multiplied by 2. That is, it is 2 cubed. So cube root of 2 cube is nothing but 2. Similarly, what is a cube root of minus 8? This would be minus 2. Why? Because minus 2 cube is minus 8. So whatever is the original number, the cube root will preserve the sign. So if the original number is minus 8, the cube root is minus 2. If the original number is positive, say plus 8, cube root is positive, that is 2. An example. Say I need to find out the cube root of 512. Now first thing I do is break down this number into its prime factors. So 512 can be written as 2 multiplied by 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 2 and so on, and 2 is basically multiplied 9 times and we get 512. That is, if I take chunks of 3, so this is 2 cube multiplied by 2 cube multiplied by 2 cube, so that is 2 cube whole cube, so that is 2 power 9. So 512 is nothing but 2 power 9, that is 2 cube whole cube. So cube root of 512 will be cube root of 2 cube whole cube. So this would be nothing but 2 cube, which is 8. So the cube root of 512 would be 8. Let's see another problem. So what is the smallest number by which 45 must be multiplied to make it a perfect square? So to find out this, we first find out what are the prime factors of 45. So 45 can be written as 3 multiplied by 3 multiplied by 5. Now if it were a perfect square, every prime factor in that would appear in pairs, that there will be 2 of each of those prime factors. Now for example, 3 is there twice, but 5 is present only once. So in case if we multiply it with 5, this would be a perfect square because I'll have 2 3s and 2 5s. So I need to simply multiply 45 by 5, which is 225, and now this is a perfect square. Why? Because this is nothing but 3 into 5 whole squared, that is 15 squared. So the answer is 5. 5 is the smallest number by which if we multiply 45, we will make it a perfect square, which is in this case 225. So from this video, there are 3 key things to remember. Firstly, regarding square roots. So positive numbers have 2 square roots. One is a positive number root and the other is a negative root. Okay, and secondly, negative roots do not have negative numbers do not have real square roots. Second thing to remember is that cube root of a number retains the original sign of that number. Thirdly, is regarding simplification. So always break down numbers into their prime factors to simplify square roots and cube roots.